Now, the thing to be careful about this, solvent amount plus solute amount equals the solution amount, is this works for most measurement units, but not for volume. That's one of those stars there. It doesn't apply to volumes. Because volumes are kind of crazy when we're talking about solutions, or sometimes kind of crazy. It applies to mass. I can add the mass of the solvent and the mass of the solute and get the solution mass. It applies to moles. I can add the solvent moles and the solute moles and get the solution moles. But I can't add the volume of the solvent and the volume of the solute and get the volume of the solution. Can't do it, not possible. Okay? And here, let me sort of explain that. It seems kind of counterintuitive, meaning runs against what seems like common sense. All right? If I take water and I was to measure the volume really, really carefully, sample of water, I measure the volume really, really carefully, and I put small amounts of salt into that water and stir it up, allow it to dissolve completely and equilibrate and everything, I can actually lower the volume of the water solution. So the water in the cup would have more volume than that same amount of water, the same mass or moles of water with the salt added to it. Okay, because the salt disrupts the way that water molecules interact with hydrogen bonding. Okay? So that seems kind of strange, but that does happen. All right? You have to have a really good way to measure volume to see that happening. You can't just use one, probably couldn't use one of our 50 milliliter graduated cylinders to see it. It's probably doesn't have fine enough measurements of volume to see it. You might, if you're really careful. Okay? So this works for everything but volumes, but nevertheless, when you put the solvent amount and the solute amount together, that is the solution. Okay? All right. So molality is one of our concentration units. Molality is one of our concentration units. Little m is what we use for molality, is the symbol we use. It actually is both the, the dimension variable and the unit of measurement. Little m is both the dimension of measurement and the unit of measurement. Okay? All right, now notice we have to have measurement of the amount of solute. Well, for molality we have moles. That's an amount. And either the measurement of the amount of solvent or solution, well, in this case we have some measurement of the amount of solvent. So molality is moles of solute over kilograms of solvent. Okay? Molality is often referred to as molal or molal concentration. Molal or molal concentration. M-O-L-A-L, molal. Yes. Molal or molal concentration. Molality. Molal or molal concentration. Okay? Kind of a tongue twister there, isn't it? Okay, all right. The next one is molarity. Please remember, molarity is a capital M with a line under it when we're writing it by hand. I understand, I'm going reviewing. Okay? We did this on the Monday before Thanksgiving, didn't we? No, we did it on the Tuesday before Thanksgiving. Okay? Okay. And we use the term molar or molar concentration for molarity. Liters of solution. Solution, that's a shorthand way of writing solution. Yes. S-O-L-N means solution. Okay, it's just shorthand. All right? And then we've got percent concentration. Percent concentration is the mass of solute divided by the same mass units of the solution times 100. So I'm reviewing. You're right, Carolyn. And Brandon, we're reviewing a little bit. Okay? All right, so now we're ready to do some conversions here. Okay? Let me talk about some conversions, review some conversions that we need for calculating concentration. Okay? Remember, if we're going to convert from mass to moles, we always have to use molar mass. Anytime you're converting from mass to moles, you've got to have molar mass. It's also true that when you're converting from moles to mass, you still have to have molar mass. Okay? Molar mass is required to convert from mass to moles. Okay? That's important when we're calculating concentration. If we're converting grams into kilograms, you need to know that the equality statement that helps us with that allows us to do that, is 1,000 grams equals 1 kilogram. Sure.
You said you convert mass to moles or moles to mass. What you do?
You got to calculate the molar mass.
Is it moles times molar?
No, it says moles going from moles to mass or mass to moles. There's the two arrows.
No, and then it says molar, no outline.
You have to calculate the molar mass. Yeah, that's how you find it. And remember, molar mass always has an equality statement at the end. Okay, we have an equality statement when you do it correctly, when I teach you to do it. Okay, and you need to know that milliliters to liters, if you're converting from milliliters to liters, that there are 1,000 milliliters in a liter. Things you need to know. Sure, you can go back the other way. From liters to milliliters, you can use that same equality statement. You might have to do that too. Okay? Now, these last two in particular come out of Unit 1, where we learned about those equalities. In Unit 1, and since that on and on, we've constantly been using conversions. Okay? We started using conversions in Unit 5, I think. But we actually practice with them in Unit 1. We practice with conversions in Unit 1. Okay? You need to know that anytime you have the prefix little m before some other kind of measurement unit, like would be like milliliters or millimeters or milligrams, that prefix means 1,000th. 1,000th of whatever the base unit is. 1,000th of the base unit. That means there are 1,000 of those measurement units in whatever the base unit is. The base, if a base unit for a milliliter is a liter.
I didn't get it. How long?
Yes. And you know that prefix kilo. Kilo. This is a little k. The prefix k for kilo. Km is kilometer. Kilometer. And what that means is that there are a kilometer is 1,000 times whatever that base unit is. A kilometer is 1,000 times a meter. So a meter stick is about this long. 1,000 of those makes a kilometer. Okay? Milli, the prefix m, the letter m before some major unit like milliliter, means there are, means 1,000th. A milliliter is 1,000th of a liter. That's what it means. And a kilogram is 1,000 times a gram. Of whatever the base unit is. A 1,000 times the base unit.
So we're going to be doing molar calculations like on the calculator?
Yes. Okay. Same stuff. Some of the same stuff. I'm going to add one new kind of calculation and then a sort of a same kind of calculation but in a different way. Okay? All right, so let's practice with this one. Here's a problem. Well, so 2 grams or 2 moles, 2.00 moles of sugar are dissolved in 2 liters of sugar solution. What is the molarity? What do you mean? Am I going to do the math? I just did. Okay, first thing we need to know is what is molarity? There you are. That's what it is. So what we have to do is arrange what we have here to give us moles of solute over liters of solution, don't we? So are there moles of solute in the problem?
Yep, 2.
Yeah, 2.00 moles of sugar. That's our solute. So you put that over, are there liters of solution listed in the problem? 2 liters of solution. All we have to do is put one over the other and divide, right?
Equals 1.
You got it. Okay. 2 moles of sugar, 2 liters of solution, sugar solution, 1 mole of sugar solution divided by liter solution, which we then can change into molar because that's what molar is. Moles of solute over moles of solution. Or liters of solution, I'm sorry. Moles of solute over liters of solution. You've got to be careful because it has to be moles of solute over liters of solution to be molarity, or molar concentration. So this is 1 molar sugar solution. That's the way I would say it if I were telling. That's the answer. Sure it is. 2 divided by 2 comes out to be 1, doesn't it?
What happens with the liters and stuff like that? How do they
Okay, moles of solute over liters of solution is molar. So moles of solute over liters of solution is molar. Okay?
So you just like you change that off.
Yeah.
So we want Neil to have to find the like
Sure you will. You have to go back the other way sometimes too. You need to know that this is the same as that and that is the same as this. Because sometimes you have to use it one way and sometimes you have to use it a different way. Okay? Does that make sense so far? How are we doing? Okay, now not every problem is going to give you the moles of the solute because we can't measure moles. How do we usually measure solids? How do we usually measure solids? Grams in mass. Okay? So how do I, if I give you the solute in grams, how do you get from grams to moles? Molar mass. We just said it a minute ago. I'll remind you of it, right? Okay, so if 2.25 grams of calcium chloride is dissolved in 1.50 liters of aqueous solution, what is the molar concentration? And what units make up molar concentration? It's not just moles. That's part of it. What units make up molar concentration?
Moles of solute and kilograms of solid.
No, that's molality.
Oh, you said molarity.
Molar,
Itsy.
molarity. It's molarity.
Moles
So
of
what
solute
units make it up?
Over liters of solution.
That's right. Molar means moles of solute over liters of solution. Okay?
Yep.
If it's molar, it's moles of solute over liters of solution. So we don't have moles in this problem, but can you find the moles? Okay? We do have liters of solution, so if you can find the moles
2.2.
and divide that answer by the liters of solution, you can find the concentration, can't you? The molar concentration. So do that, please. Huh? Well, you've got to get it into moles of solute over liters of solution to find the molar concentration, right? Well, we've been converting grams to moles for 6 weeks, haven't we? Okay? So convert the grams of calcium chloride into the moles of calcium chloride. Can you do that? We're doing it repeatedly for 6 weeks. You can't do it still? Really? Mm-hmm. What do you have to do to go from mass to moles? Molar mass. Exactly. Do it. Yep. Find each of the masses of all the atoms in the formula. Put them together. Make sure you write the equality statement at the end. Do the conversion.